Hello students, welcome back to the next module of the chapter Oscillation. Students, in the last two modules we have seen a very important term called as phase of SHM. In this module students, we'll see one more important term which is nothing but called as initial phase or epoch of SHM. So let's start students. As we know students, the displacement of the particle in SHM at any instant is given by the equation x is equal to a sine omega t plus alpha. Students, in this the phase of SHM is omega t plus alpha, which we have already seen in the last two modules. Students, if I substitute t is equal to 0 here, let's find the phase of SHM. So let's see at t is equal to 0, what is the phase of SHM? So let's put the value of t is equal to 0 in the formula of phase, and we get omega into 0 plus alpha, which is nothing but alpha itself. You remember students, alpha in our phasor diagram? Yes, was the initial angle made by the particle at the mean position. And if you remember, I had already introduced this word initial phase angle or initial phase. So can I say students, alpha is nothing but phase of SHM, but at time t is equal to 0. This alpha is nothing but called as initial phase, also called as phase constant or epoch of SHM. So in the expression omega t plus alpha, alpha will be called as initial phase. So let's define it students. So can I say the phase of SHM at t is equal to 0 is called as initial phase or epoch. Students, phase, the word phase is coming in the definition. We know phase indicates the state of oscillation, and state of oscillation means two things, that is the magnitude of displacement and the direction of motion of the particle. Now in phase it was at any instant, but in the case of initial phase, no doubt we are again getting phase, but this time at time t is equal to 0. Therefore, I can also define initial phase as, yes, we can define it as a physical quantity which again describes the state of oscillation of particle performing SHM, but at t is equal to 0, that means at the start of motion. Remember students, whether phase or initial phase, both are describing the state of oscillation, but the difference is whenever I say phase, it is at any instant, and whenever I say initial phase, it is always at the start of motion or at t is equal to 0. Let's understand students through a small example. Say initial phase is 0. So if I put t is equal to 0 in our equation of motion, x is equal to a sine omega t plus alpha, if I put t is equal to 0 students, I get only x is equal to a sine alpha. Let's put alpha is 0. We know sine 0 is 0, therefore x will become 0. This indicates that whenever initial phase is 0, the particle is at mean position. Let's get back to our phasor diagram students. As you know, we'll measure angle from OD in anti-clockwise direction, and alpha 0 indicates that the particle is at point P. So let's draw a perpendicular, and we know this particle will be at O itself, that is displacement is 0. So when the initial phase is 0, particle is at mean position. But where is it moving towards? So as we know, whenever it is 0, the particle is moving towards, yes, it is moving towards positive extreme. So I can say initial phase is equal to 0 degrees signifies that the particle starts the motion from mean position, yes, moving towards positive extreme. Students, important point to be noted here, when I say phase 0, at that time we had written particle is at mean position, but when initial phase 0, we'll always write starts its motion from mean position. The two terms are same, mean position and moving towards positive extreme. The only difference is whenever phase we'll write is at mean position, and whenever initial phase starts its motion from mean position in this case. Let's note down some important points for entrance students. Students, we'll have 4 standard cases to remember as far as entrance is concerned. Now, whenever initial phase is 0, we should know where does the particle start from and its direction of motion. So students, remember, whenever initial phase is 0, we should always remember the particle is at mean position. And we understood that it is moving towards positive extreme. Second case, whenever the phase is pi by 2, we know phase angle pi by 2 or initial phase pi by 2, particle is at point B, that is, it is at positive extreme and will move towards, yes, it will move towards the mean position. Third, when the phase is pi radians, we again know particle is at mean position, but will move towards the left extreme or negative extreme. And the last case, whenever the phase is 3 pi by 2, that is 270, we know the particle is at point A, that means the particle is at negative extreme and the direction of motion will be towards the mean position. Important point, students, look at initial phase 0 and pi. In both the cases, particle is at mean position, but 0 initial phase means the particle is moving towards positive extreme, and pi initial phase indicates the particle is moving towards negative extreme. That's all in this module, students. See you in the next module.